In this video, I am going to explain turns on and off a light emitting diode when pressing a push button. Turns on and off of a light emitting diode when pressing push button. This one is the diagram. This one is Ardunio board. Yet consider 13th pin and 5th pin. The LED is connected to 13 pin. The anode of the LED is connected to 13 pin through resistor. The resistance value is 220 ohms. This one is anode. This one is cathode. Ground. Next, here 5 volts. We consider from this Arduino 13th pin, 5th pin, and 5 volts and ground. This ground is connected to 5 volts. This 5 volts. This 5 volts is connected to push button here shown in figure. The 5 volts with the 5th pin is connected here. Some 10 kilo resistance. This one is the push button. This one is push button. Generally, push button shown in figure here. Four points here. This one is a push button. 1, 2, 3, and 4. Simply it is represented as 1, 2, 3, 4. Under normal condition, there is no contact here. This is the normal. Under button pressure, here 1, 2, 3, 4. The connection is like that. The connection is like that. Short circuit here. Here pin numbers 1 and 3 are internally connected, and 2, 4 are internally connected. This is the push button description. Whenever the push button is unpressed, that means the 5th pin of an Arduino is connected to ground through 10 kilo ohm resistance. The 10 kilo ohm resistance is called as a pull down resistor. Therefore, output is low. Here, because the 5th pin is connected to the ground 10 kilo ohm resistance. Therefore, output is measured at this point is very low. Fifth 5th pin is low. In another case, in pressure condition, the switch is under pressure condition. Some short circuit is created here. This 5 volt is directly connected to 5th pin of an Ardunio. Therefore, here the output is 5 volts. That means high value. Under unpressed condition, there is no connection between this point and this point. Open circuited condition. The 5th pin of Ardunio is connected to ground through 10 kilo ohm resistor. This 10 kilo ohm resistor acts as a pull down resistor. Their output is 0. That means low value. Whenever that switch is pressed, a connection is created between this point and this point. Therefore, the 5 volts is connected to 5th pin of an Ardunio. Therefore, output is very high under pressing condition. These are the two important points, very important points here. When push button is open, when push button is open, that means unpressed condition. So the pin is connected to, so the pin 5th one is connected to the ground through pull down resistor. And we read a low value. And we read a low value. Next, second important point here is when button is closed. When button is closed, that means this one. When the button is unpressed means this one. When the button is closed, it makes a connection connecting the 5th pin to 5 volts. Connecting the 5th pin to 5 volts. So that we read a high value. So that we read a high value. This is the actual description of that switch here. This is a switch or push button. Compressor mode and uncompressed mode. Uncompressed mode means this 5th pin of an Ardunio is directly connected to ground through pull down resistor 10 kilo ohms. Therefore, we read low value. Compressed, pressed condition. This 5 here short circuit is created. This 5 volt is connected to 5th pin of an Ardunio. Therefore, output is very high. So that we read a high value. Here we use now sketch. Program. Here we use 2 pins. 13th pin of an 13th pin acts as a output. Here 5th pin of an Ardunio is acts as input. Input to the push button. Here we use configure these 2 pins in the setup case, and also the control of this LED, that means on and off, depends on the push button pressed or uncompressed state. That means high value or low value. Based on that one, we have to write the program here. Here initialization part is there here. Integer, push button, is equal to here push button pin is here push button pin is 5. Next one, integer LED pin. LED pin is equal to here LED pin is 30. LED pin is 30. Next one, integer button state. Button state is equal to initially 0. By using these initializations, have to configure these pins void setup. Here some gap is there. Void setup. Here we have to introduce one more important statement. Here is curly bracket is open. Serial, S is capital, SERIAL. Serial dot begin 9600 baud rate. The communication between that computer and the Ardunio board at the bit rate of 9600 bits per second. Here configure these two pins, 5th pin and 13th pin. Pin mode, that is the pin mode. Here push button. Push button, that means input. Why this one is input? Based on that pressed or unpressed of that push button, how to glow the LED. That means our output. Therefore, input is the push button, output is the LED blinking. Pin mode. LED pin, comma, output. Next one, void loop. Here, one more important function used here is digital read. Because here some input is there. Input to the push button from Ardunio. That means here we use a digital read function. Digital read bracket pin number. Read the value from a specific digital pin, either high or low. It indicates read the value from a specific digital pin, either high or low, because the 5th pin is the digital pin. That pin is applied to push button. That is the digital read pin. By using this one, we have to write the program. Here button state. Here push button is equal to 5. Here we use one more parameter, integer button state. S is capital. We use a digital read. Digital read. Here pin in case of pin we use a push button. Here push button is 5. Push button. Push button. Here one more important statement here used is serial. S is serial. Serial dot print ln. Here button state. Here need not to use here integer because already declared. This one. If button state means either pressed or unpressed. Pressed means I state. By using this one, button state high, that means pressure case. Digital write. Digital write. LED pin high. LED pin means the 13th pin high. Here we use a small delay 30 milliseconds. Digital write LED pin low. Therefore, task is over. Here we use closing curly bracket for if statement and closing curly bracket for execution loop. This is the program concept. Totally based on that push button condition, either pressing condition or unpressed condition, the LED is blinking. Now next step is now we will see this one in Tinkercad simulations. Create new circuit. Pick up the components. Pick up the components. Here, this one is a switch here, and one breadboard, one LED. LED. Next one, Ardunio board. Pick up the Ardunio. Pick up the Ardunio board here. Some resistance values are also important. Resistor 220 ohms and 10k ohms. 220 ohms and 10k ohm resistors. Using this circuit, this one, 13th pin is connected to LED anode and LED cathode is connected to ground. 13th pin is connected to LED anode through 220 ohm resistors. Here 5th pin is connected here. This push button has 4 legs, 1, 2, 3, 4. 1 and 3 are internally connected. 2 and 4 are internally connected. That 5 volt is connected to this third one because 1 and 3 are internally connected. Here fourth pin of that push button is connected to 5th pin of Ardunio, and the 10 kilo ohm resistance is connected between that fourth pin or fourth leg to and ground. The 10 kilo ohm resistance is placed in between fourth leg of that push button and ground. That fourth leg is also connected to 5th Ardunio pin. These are the connections we have to make here. See this one. The switch is placed here. This one is the 1A, 1B, 2A and 2B. This one is LED placed here. Here 220 ohms. The 220 ohms is connected to 13th pin. See the 220 ohms. See this 13th pin. The 13th pin is connected to here. This one is anode. This one is ground. Ground is connected here. Change the color. Black here. This one, right click and change the color red like that. Next one, this is the 10 kilo ohm resistance. Here we use 10 kilo ohm resistance. The 10 kilo ohm resistance is connected to one leg. This is connected to ground. And fifth pin, input pin. This one is fifth pin is connected to this one. And 5 volts. This one is 5 volt source. From this one, I have to choose ground. Ground is connected. These are the connections. Connections are completed. Here in the previous case, here 13th pin for LED and 5th pin for push button. This 5th pin is the input pin. 13th pin is output pin for LED. Already declared. See this one. This is the push button. 4 legs. 1, 2, 3, 4. This one and this one are internally connected. This one and this one is 2A. This one is 2B internally connected. Here 5th pin is 5th pin of Ardunio is connected to one leg of that push button. Okay. Connections are completed. Next step is write the program here. Code, text, integer, that is integer, push button, push button value is here we use push button is 5. One integer LED pin. That is LED pin is 13th one. 13th semicolon. Next one integer. Button state also important. Push button, that means that button that push button is connected to 5th pin already declared here, and the button state is also initially 0. How to assign the button state. Whether it is a high or low based on that pressed or uncompressed. Button state is 0. Next one void setup. In the void setup, speed up that operation between that computer and the Arduino board is very important. Here serial SCRIAL SCRIAL serial dot begin serial dot begin 1600. Here pin mode LED pin declared here. That means output pin 1. Pin mode push button push button push button, that means input. 5th pin input completed. Next one is execution block. Here button state. button state is equal to digital we use a digital read push button. Here digital value is digital read from fifth pin. Fifth pin is assigned to push button. Here we can write push button. Push button. Semicolon is not used here. Here serial begin serial begin. This is the capital one. Serial dot int ln button state. If button state, that means pressed or uncompressed state. If brackets button state high, button state is high means compressed pressed state. Digital write LED pin high. That means 13th pin. LED pin, comma delay delay 10 seconds, 10 milliseconds. Digital LED pin, digital write LED pin low. Here we use a closed bracket for statement and closed curly bracket for execution blocks. This one is a button state means pressed state or unpressed state. Here we use a serial dot print ln. We will see this one. Serial monitor. Here button print ln. Here some error is there. Here button state Here 14.6 if button state. STA, here something is not written here. Button state is high. In 15.5, error digital write was not declared in this scope. Here digital write. Right here. Okay. Serial monitor here. Here that push button is pressed. Here all ones are there under serial monitor. All ones are there. That means high value. Already explained. The LED is glow. Pin mode LED pin push button is high value. Under released all are zeros and LED is off. Here delay is 100 milliseconds. Instead of 10, here we use 100 milliseconds. Here zeros are slowly converted to ones. Start simulation and press the push button. Here zeros are converted slowly because 100 milliseconds. 1, 1, 1, 1. The LED is on. The LED is on. Instead of 100, we use 10 milliseconds. Here zeros are converted into fast, very fast. And LED is on. And release the push button and press the button. And all are ones, LED is on. And release the push button, all are zeros, LED is off. Here the serial.println button state is indicate this value in the values are indicated on the serial monitor with the help of this one. And also speed rate is very baud rate is very important. Serial.begin 9600. These are also very important. Thank you. Here indicate some LED blinking. LED blinking using push button. Value of push button is very important. The value of push button is from digital pin 5 only. Digital read, not write. That means pin 5th pin is the input pin and 13th pin is the output pin. Okay. With this completed. Press the button and LED glows. Release the button, LED is off. Thank you.